In this video, I will show you how to print the prime numbers between the given range. Suppose if I entered 20, it will list out the prime numbers between 1 to 20. If I entered 30 or if I entered 100, it will print the list of prime numbers between 1 to 100. So what is the definition of a prime number? If a number is successfully divisible by 1 and itself, then that number is called as prime number. So using this logic, we will try to solve this problem. First, open a new source file. Include the relevant header files that are required for our application. So we need one standard header file, that is stdio.h. Then begin the function, main function. So here we need to think about how many variables are required for our application. So we need to collect the input value from the user. So always we are trying to generate the prime numbers from 1 up to the given number. So 1 is the starting value, but up to what number we want to print out. So that number we are collecting from the user, and we need to maintain a count because we need to test that number, entered number is successfully divisible by how many input values, that is count value. And we need to run two loops. So for that we need two more variables, that is called as loop control variable I and loop control variable j. So why we need two for loops, I will explain later. So first we need to collect an input value from the user. So we are asking user to enter a number. By seeing this message, user will enter a number. So immediately we need to scan it. Whatever the number that is input value that is entered by the user, that we need to scan it. Our input variable name is n, so we are using ampersand n to read the input value. Now, so what is our aim? We need to print the list of prime numbers between the given range. Between the given range means beginning from 1 up to the given number. Each time we need to increment the number. And here we need initially, before testing a particular number is a prime number or not, we need to set the count value as 0. So here no need to initialize here. Here just we are declared it, that is initialized here. And after that we need to start one more for loop. Outer for loop is read each number individually. So outer for loop is, suppose my entered input value is 7. This loop runs from 1 to 7. So our job is we need to test 1 is prime or not, 2 is prime or not, 3 is prime or not, 4 is prime or not, 5 is prime or not, 6 is prime or not, 7 is prime or not. So we need to test is 1 is a prime number or not. We need to test 2, 3, 4, 5, 6 and so on up to 7 is prime or not. So how can you test is 1 is a prime number or not? If you want to test 1 is a prime number or not, we have to start dividing that number from 1 to up to that number. If I want to test 2 is a prime number or not, we need to start dividing with 1 to up to that number. If I want to test 4 is a prime number or not, I want to test that, I want to apply division operation to check the remainder value starting from 1 to up to that number. See, if I want to test 4 is a prime number or not, no need to checking the remainder values when it is divided with 5, 6, 7 above numbers. Up to that number, that is enough. So for that, I'm using one more for loop. This for loop starts from 1, but here we need to keep the condition that is up to the given number only. We need not test with the rest of the numbers. Now, so I is equals to 1 to 7. So here j is equals to, for example, in a particular iteration, if I value is, after some iterations, I value is 3, then this j loop runs 3 times. This j loop runs, why? Because I value is 3 means j is equals to 1, it is true, j is equals to 2, it is true, j is equals to 3, it is true. So it will run 3 times. Here the above outer for loop control variable should successfully divisible by inner for loop control variable. Then if it returns remainder 0, then we are incrementing the count value by 1. Okay, count value by 1. After come out of the inner for loop, we are testing is that count is exactly 2 or not. If it is exactly 2, what is our aim of the program? To print the prime numbers. Only we are printing, we are not displaying any messages, we are printing the list of prime numbers. So what we are trying to do, so printf, here we are trying to print that particular prime number. What is our prime number? I. Our prime number is located in the variable I. When I is equals to 1, if 1 is a prime number, it prints I is equals to 2. If 2 is a prime number, it prints 2. If I is equals to 3, if 3 is a prime number, it prints 3. If 4 is actually not a prime number, then it won't print 4. So how can this application knows that 4 is prime number or not? Based on this logic. Based on this logic, if it is count exactly generates 2, then only it prints. Otherwise, it won't print it. So like this, we can do it. So here, suppose after some iterations I is equals to 3, it will test reminders for 3 modulus 1, 3 modulus 2, and 3 modulus 3. No need to test with 3 modulus 4, 3 modulus 5, and 3 modulus 6 like that. So here how I got 3, just I am assuming that after some iterations my I value is 3. Then my j value starts from 1 up to 3 only. So 3 modulus 1, 3 modulus 2, 3 modulus 3. If it is exactly divisible, successfully divisible by 2 numbers, not more than that, not less than that, because any number, it is a universal truth. Any number is successfully divisible by 1 and itself. Definitely the count should be at least 1. Count should be at least 2. If it is more than 2, then we can declare we need not print that number. Why? Because it is not a prime number. Our aim of the program is printing the only prime numbers. So here, before printing the prime numbers, we can also keep a message here: prime numbers between 1 to percentile d. What is this percentile d? That is n. And here we need, in the next line we are going to print the list of prime numbers. So apply new line. Here also we are going to print the prime numbers line by line. So we need to apply new line here. So save this program with a valid file name. Compile this program for checking errors. So we don't have any errors and we don't have any warnings also. Now run this program. Suppose if I entered 50, so then what it is going to print? It will print a message like prime numbers between 1 to 50. Then it will list out what are the prime numbers. You can check it. Prime numbers between 1 to 50. Is 2 is a prime? Yes. 3 is a prime? Yes. 5 is a prime? 7, 11, 13, 17, 19. See, if 23. 23 is only divisible by 1 and 23. No other number is divisible 23. 29 is also divisible by only 1 and 29. 37 is also divisible only 1 and 37. 43 is divisible only 1 and 43. 47 is divisible only 1 and 1. So, for if you consider 8, 8 is not printed here. Just I am saying that 8 means it is successfully divisible by 1. It is also successfully divisible by 2. It is also successfully divisible by 4 and 8. That means more than 2. The count value is more than 2 for 8. Similarly, if you consider 4, actually 4 is not printed here because it is not a prime number. 4 is successfully divisible by 1, 2 and 4. So more than 2 count values are not printed here. So how it works out? You can check this logic. So why I'm using 2 for loops here to solve this application? Why? Because the outer for loop is to read numbers from 1 to up to the given number. The inner for loop is to check that particular number, that particular number I is prime or not. I am checking here. I am checking here I is prime or not. This inner for loop purpose is to check that particular number is stored in which variable? I. Is that particular number is, that's the reason if you see here in I modulus j, in all cases numerator is common, only denominator is changing, only denominator value is changing. So what is the denominator variable? J. J is rotating, from 1 to up to that particular number I. So that is the reason. So for if I value is 4, then this loop we will run 4 times. If I value is 5, then the inner for loop runs 5 times. If the I value is 6, then the inner for loop runs 6 times. So like this, using this logic, we are trying to test the printing the list of prime numbers beginning from 1 to up to